We'll start with Mercury. Mercury is a planet closest to the Sun, orbiting at an average distance of about 35 million miles, 58 million kilometers. Like all the Rockies except Earth, Mercury is named for a Roman god. Mercury was a winged-footed messenger famous for speed. Indeed, the planet Mercury moves faster than any other, rushing around its orbit path at nearly twice Earth's rate. Every hour, Mercury travels more than 100,000 miles, 160,000 kilometers. Mercury's high speed overcomes the Sun's intense gravity and keeps the planet from being pulled into a fiery death. Mercury zooms around the Sun in just 88 days. On the other hand, it rotates on its axis slowly. Rotation on an axis gives planets day and night. Between sunrises on Mercury, there are 176 Earth days. Mercury is our smallest planet. Its diameter is less than half of Earth's. In fact, Mercury is only 1.5 times the size of our Moon, and smaller than some moons of Jupiter and Saturn. Mercury's surface even looks like our Moon's, with thousands of craters. These craters, like those of our Moon, reveal a history of bombardment by meteorites and other space objects. Most of the strikes probably occurred billions of years ago, when our young solar system was more crowded with rocks and other debris. The rocks and debris have been gradually swept out by planets or pulled into the Sun. Long ago, Earth may have been heavily cratered too, but nearly all traces of the ancient craters are gone. Earth's surface, unlike those of Mercury and the Moon, constantly changes. Two forces do most of the remodeling. The first is tectonic plate movement. Earth's crust is cracked into over a dozen pieces called tectonic plates, which move very slowly. Over time, these tectonic plates split apart, bump, and crash into one another. Sometimes tectonic plate movements violently recarve our planet's surface with earthquakes, volcanoes, and rising mountains. The second force working on Earth's surface is erosion. Water and wind wear away high spots of land and fill in low ones. Slowly but surely, erosion and tectonic plate movements have erased most signs of Earth's early history. By contrast, Mercury's pockmarked surface seems stable. There are no signs of plate movements, and erosion occurs slowly, if at all. Mercury has almost no atmosphere. Atmosphere is necessary to create eroding winds and rains. Mercury is too small for its gravity to hold light atmospheric gases. Atmospheric gases such as hydrogen, oxygen, and nitrogen are regularly emitted from Mercury's rocks, but they simply float into space. We would find Mercury a poor place to live. Rocky, hilly, and empty. It also lacks oxygen and has temperatures unsuitable for life. Traveling farther from the Sun, we meet Venus, named for the Roman goddess of beauty. Venus is the brightest planet in our night sky. It's often easy to spot near the horizon at twilight. Venus is slightly smaller than Earth, but has a denser atmosphere. In fact, Venus's atmospheric pressure is 90 times heavier than ours, mainly because its atmosphere is mostly carbon dioxide. Carbon dioxide is extremely heavy gas compared to the nitrogen and oxygen that dominate Earth's air. Even though Venus is farther from the Sun than Mercury, its average surface temperature of 864 degrees Fahrenheit, 462 Celsius, makes it the hottest of all planets. Venus's extraordinary heat arises because of what is known as the greenhouse effect. The greenhouse effect traps heat and works like this. Waves of energy leave the Sun. These energy waves include X-rays, ultraviolet waves, radio waves, and others. But the highest percentage of energy waves falls in the visible light spectrum. These light rays pass right through Venus's atmosphere without warming it. However, Venus's rocky surface absorbs them. This heats Venus's surface. The surface then gives off or radiates much of the energy, but in different wavelengths than sent by the Sun. These particular energy wavelengths, mostly in the infrared spectrum, are absorbed by Venus's atmospheric gases, where they more or less get trapped. This leads to Venus's surprisingly high temperature, which is hot enough to melt lead. A greenhouse for gardens on Earth works much the same, except panes of glass trap heat. Earth's atmosphere also creates a weak but important, delicately balanced greenhouse effect. Venus is not only the hottest planet, it also rotates backwards. On most planets, the Sun rises in the east. On Venus, it rises in the west. Some astronomers believe that Venus got knocked head over heels in a collision with a comet. And now sits upside down on its axis. All planets, and even the Sun, tilt on their axis, but none do this as much as Venus, which leans at an angle of 177 degrees. Earth and Mars each lean about 25 degrees, just a small fraction of Venus's radical tilt. While Venus is Earth's closest neighbor, it is unlikely we would ever want to live there. Overlaying that heavy atmosphere, which causes the planet to be hotter than an oven, are thick clouds of strong sulfuric acid. All spacecrafts which have landed on Venus stopped working immediately because of the planet's heat, pressure, and sulfuric acid. At 93 million miles, 149 million kilometers from the Sun, conditions on Earth are just right for life as we know it. Though we receive less than 1/1000th of the Sun's heat and light, it is enough to keep us warm, in part because our atmosphere provides some help with the greenhouse effect. Astronomers call the distance from the Sun to Earth an astronomical unit, or 1 AU. AUs provide a handy ruler for measuring distances in the solar system. For example, Mercury is 0.39 AUs from the Sun, Venus is 0.72, and Neptune 30. AUs are also used to describe planet distances around other stars. In countless ways, Earth is finely tuned to support plants and animals. An abundance of water, varying weather, a coating of soil, and the presence of oxygen all help support Earth's colorful tapestry of life. However, it is beyond this show's scope to closely investigate Earth. So let's now look at Mars, the last of our rocky neighbors. This red-tinted planet, just over half the size of Earth, is named for the Roman god of war. Robotic rovers placed on Mars show a surface full of craters and volcanic mountain peaks. None of the volcanoes are active, but Olympus Mons stands 3 times taller than Mount Everest and is the largest volcano in the solar system. Mars' rugged surface shows some signs of erosion. Perhaps water once flowed freely on the planet, which long ago may have had a warmer climate. Mars still has some surface water, most of which is frozen in polar ice caps. 2 things may have contributed to a warmer past on Mars. First, its volcanoes once released lots of gases. These formed a thick atmosphere which held in heat through the greenhouse effect. However, Mars was unable to hold the atmosphere because of weak gravity and interactions with the solar wind. As the atmosphere floated into space, the planet's temperatures fell. Second, Mars' axis wobbles and moves, like that of a slowing top. A combination of various movements in the direction of the North Pole axis, called the Milankovitch cycle, takes over 100,000 years. When the axis tilts a certain way, it leads to a colder world, as is the case now. Mars' current average surface temperature is below Earth's by at least 50 degrees Fahrenheit, 27 Celsius. Still, at Mars' equator on a hot day, we could find the temperature quite pleasant. Among our rocky neighbors, and indeed among all planets, Mars seems the most friendly to visit. Beyond Mars lies a wide belt of space dotted with small chunks of rock and metal we call asteroids. After this asteroid belt, we encounter the outer planets. These are giants. They have little rock or metal, and instead are constructed of layer upon layer of hydrogen and other gas. In this cold, distant part of the solar system, much of the gas is frozen, but the outer giants also have deep, swirling atmospheres and feature exotic colors and fabulous rings and moons. We would surely find the planets cold and hostile, after the more familiar terrestrial worlds of the inner planets, our rocky neighbors.